Alright, super nerds, let's talk about sex linkage. So, by the end of this, you want to be able to explain what sex linkage is and give an example of a sex linked trait. We're going to talk about color blindness, and you want to use a pedigree chart. For example, about color blindness, here we have one image which has had a filter put on it to show you how it would look for a person with fully functioning color rods and cones and someone who has the condition of color blindness. In fact, red-green color blindness in particular. We'll have a look at a few examples of what the difference is. So, you need to remember from previous lessons, humans have 23 pairs of chromosomes. The 23rd pair of chromosomes is the sex chromosomes. It is the X and Y chromosomes. And these are what give you your male and female characteristics. For example, males have XY chromosome pairs and females have XX chromosome pairings. Now, you also want to be able to do a pedigree, and this is how pedigree works. Basically, we use pedigrees to chart and track genetic conditions through families. These are the symbols you need to know, so I'll draw this and have these down. So square means male, circle means female, a line through it means that person is deceased. Okay, you can see it looks like a flow chart. A coloured in square means it is an affected male, coloured in circle means an affected female. So for example, let's have a quick look. Here are the parents, the first parents that we have information on. The ones that come directly down are the offspring. Okay, so these unaffected parents had 2 affected children and both were male. Let's have an unaffected male and an unaffected, they only had males. Two unaffected males, so half-half. I would say this condition is not sex linked. Anyway, as we go down, you can see this person here is someone that is a partner, or so co-parent with this partner here. Oh no, they did have a female. There we go. All right. So, what is sex linkage? Basically, it's the physical association of genes with the sex chromosomes of eukaryotes. So that's you're a eukaryote, and the sex chromosomes. So if a gene is on the X or Y chromosomes, they are sex linked. So the X and Y, they carry the ones that determine male and female characteristics, but they also carry many other genes. Now, the genes which are carried by either chromosomes are said to be sex linked. We've covered that already. And here's a quick example. So here we have a father with XY chromosomes. That's how it tends to work. Mother with 2 X's. And we've got an affected father. Okay. What you'll notice, and this is the interesting thing, is he is unable, if it's the affected father on the X chromosome, to have affected sons. All his sons are unaffected because the father will give every single time he will give the child a Y chromosome, the boy children a Y chromosome, and he also gives the daughters an X chromosome. So you see, 100% of his children that are females will have whatever the condition is, and the reason is he only gives the daughters X chromosomes, and one of his X chromosomes only gives the boys Y chromosomes. If this was on the mother, it would be split 50-50 on either one. And here we have which we're about to see now. So we have an unaffected father and an affected mother. Okay, and what we see is that 50% of children of either gender get it because the mother gives only X chromosomes, and she's got 2 to give, so it's a 50-50 split which one you're going to get. Let's look at color blindness. Okay, so color blindness, it exists on the X chromosome. Okay, so if we've got a mother who is a color blindness carrier, oh, by the way, with pedigrees, if it is half colored in, that person is a carrier for the gene. So they have the gene, but it's not expressed in them. All right, so this mother would have a circle that would be half colored in, and the father would have a square which is not colored in at all. This child would have it's a boy, it would have a fully colored in circle, empty circle, square which is half colored in, and empty square. Alright, so we do this, we get and boom, 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 boom. So that's the pedigree there. But let's get rid of that now, and we'll talk about it. Okay, so she's a carrier, which means she has the normal allele and the defective allele. She'll pass that on to 50% of her daughters and on to 50% of her sons. Okay, so there's a sex-linked chromosome. If this was on the father's gene, so this boy here, when he has children, every single child of his who is female will get the gene. So all of the females will get the gene there. None of the males will from him. Okay, so that's why we start to get on. Now, this is essentially the difference for color blindness. We're going to look at a pedigree in a little bit. This is what it looks like with regular sight, healthy sight, and this is red, green color blindness. And you see the red, it disappears into the yellows, and the greens, the purples and blues, purples and greens, they disappear into blue. So this is what apples look like for someone with red-green colorblind. They can't tell the difference. And here's another way to look at it. So there's a colorblindness simulator online, and if you upload an image, it will apply a filter to it to how people with red-green colorblindness see it. And here is a pedigree. Okay, so we have an affected male, an unaffected female. Cool. None of his boy children can be affected because he gives them a Y chromosome. Okay. Of his daughters, all of the daughters will be carriers. It's the next generation where we see it start to pop up. Often you'll hear about things they say it skips a generation. A genetic condition skips a generation. Usually, in that case, we're talking about sex-linked traits. So sex-linked traits, they're the ones who tend to skip generations. And that's because here we've got the one of the daughters, when she becomes a mother, half of her sons will have it. But if the father's unaffected, all of the daughters can only be carriers. Okay, so he's got an unaffected father, so they get an X, like she gets an X from dad and an X from mom. Okay, so because dad is unaffected, she can only, this one here is not a carrier. This one here is a carrier, but they cannot be affected by it. But again, their children can. So yeah, we'll go over that a bit more in class just to iron out the kinks, and we'll see you there.